everybody. How are you doing? I'm excited to talk about the sun today. I'm so glad you're here. I've got my NASA shirt on. You know what NASA is, guys? Let me know in the chat if you know what NASA is. Hey, Joanna. Hey, Yolanda. And I talked to Brandon. Lots of fun stuff. I've got my necklace on. My necklace, I'll explain in a second. Yes, Brandon, good. It's a U.S. Space Center. So NASA just got the Mars rover to space in July, just like China got their rover to space, and they're both now at Mars. So the USA's rover Perseverance, we call him Percy for short. He's on Mars and he's taking cool pictures. And then China's rover is still in orbit because China's looking at the atmosphere right now around Mars, and they'll land in May. So lots of cool stuff going on in the solar system. Even one of our rovers, Perseverance, has a little helicopter on it called Ingenuity, and it's going to fly around and take pictures in about 2 months, maybe a month to 2 months. Anyway, lots of cool pictures. I've already seen a sunset on Mars. I've seen all kinds of neat stuff. So we're going to talk about Mars probably next month. I've got that date already scheduled in March. Today we're talking about the sun. So if you guys look at my necklace, like I just talked about, let's see if I can get this a little bit closer. My necklace has all the planets. Can anybody guess what that big yellow orangish stone is? Anybody know? These are all the different planets. This is supposed to be the solar system. Anybody know what this thing is? This big orangish brownish stone? Yeah, good. It's the sun. Yeah, the sun. And Brandon thought it was Jupiter, which is fine, Brandon. I would too if I looked at it because Jupiter's the biggest, right? But they do have the sun on here. So we'll talk about Jupiter another month to another webinar. So it's supposed to be the sun because they're all going around the sun. I've also got my model I'm going to show you guys in a little while. Okay, we've got the sun here, the moon, and the earth. And we'll talk a little bit about that in a couple minutes, okay? All right, let me go ahead and continue. Tell me where you're from. I think I see everybody I normally see that's familiar to me. I'm so glad you guys are here. And I got to see you guys yesterday, too. We talked about Snoopy and Charles Schultz. Yep, Brandon's Beijing. Who else have I got? I see Yolanda, who I normally see at webinars. I see Joanna, who I see every week because I teach. I see, Yep, Yolanda's Canada, Joanna's Shanghai, Ellie, and of course, hopefully Austin is there too, because Austin, I'm going to ask you about this tomorrow in our class. Bella's from Beijing. Hi, Bella. Anybody else? I see Mark. Okay, good, Ellie. Okay, I'm not sure who the one from Shizhu is. Hey, Jerry. Jerry, where are you from? Anyway, continue letting me know. I'm going to go ahead and start because I've got lots of neat stuff to talk about. We've got a book on the sun. I'm going to talk about all aspects of the sun. Let me show you this first. And I'm going to switch between screens like you guys normally see that I do. And Jerry's from Shanghai. Great. Okay, so here's Mr. Sun. You should be seeing it now. Okay, so there's the sun. He's got some cool shades on. You should always wear protection on your eyes and on your skin. We'll talk about that also today. So if I was looking at this outside, I would not look directly at the sun. Okay, not good to do. The sun is the brightest star in our sky. It's what we all go around. That's why I have my necklace on. All the planets go around one star. Okay, this is our closest star, and it's 93 million miles from us. You guys know it provides light and warmth even on a cold, cold day. If you get in the sun, it's a little bit warmer. This continues to burn and burn and burn. It's made of hydrogen and helium. So the sunlight that you saw today left the sun 8 minutes ago. Okay, so we're on opposite sides of the earth. Okay, you guys are over here on the dark side. I'm on the light side here because the sun's just coming up here in my home, and the sunlight that I'm seeing right now, though it's kind of a cloudy day, left the sun about 8 minutes ago. Okay. And we call us the Goldilocks planet. If you've ever heard of Goldilocks, she was in the bear's cottage in the forest, and she had the porridge or the soup. And, one porridge was too hot, one was too cold, one was just right. She had a chair that she went and sat in. One was mama bear and daddy bears and baby bears. One was just right, but one was too hard and too soft. We're the Goldilocks planet because we're just in the right spot from the sun to have liquid water and ice and the right kind of air we can breathe. So the other planets are not the right spot from the sun. They're too cold or too hot, or they have no atmosphere. I'll be talking about a lot of the planets in the next couple months. Okay, and there's different parts of the sun. We'll talk about those in a second. Do not ever look directly at the sun. It will hurt your eyes unless you have a solar telescope. That is one way you can look at the sun. There's also another way if you're going to look at a solar eclipse. We'll talk about what an eclipse is in a few minutes. All right, let me go ahead with the book. And what is the sun? Okay. What is the sun? At night, tiny lights dot the sky. These lights are stars. Stars are glowing balls of gas and that give off light. Thousands of them can be seen from Earth. Most stars look very small and can be only seen at night, right? But they are actually really large. Stars just look small because they're so far away. One of the most famous stars is one we see every day. This is our sun. It is the closest star to Earth. And because the sun is so close, it appears large and bright in the daytime sky. Now, here are the parts I just showed you. I'm going to talk a little bit about those. There are many different kinds of stars. Scientists group them based on size, mass, that's how heavy they are, brightness, temperature, and color. Our sun is a dwarf star. Dwarf stars are medium-sized stars. At the center of our sun is its core. See the little part here? Almost like if you're eating an apple, it has a core, right? At the center of our sun is the core. The core is filled with gases, so it's not really solid like you would think an apple core is. The Earth has a core. It's solid iron, okay, and nickel. It's really heavy because when stuff spins, it goes faster and faster, and the heavier stuff goes to the middle. So this is filled with hydrogen and helium. The surface of the sun is called the photosphere. I always think about taking a photo, a photograph, a picture. That's the part that you see of the sun. It is much cooler than the core. The sun's surface is surrounded by the chromosphere and the corona, kind of like we talk about the coronavirus, but this corona means crown. Okay, these layers of gases form the sun's outer atmosphere. They're hotter than the sun's surface. So the only time I see the corona, the outer part, is during an eclipse. And also NASA just sent a solar probe not to land on the sun because you can't land on something that you can't stand on, right? It's gas. You go right through it. Anyway, they just sent something to get the closest pictures of the sun that we will ever get. It's kind of cool. You could fit 1 million Earths in the sun. That's how big it is. You could fit 1 million Earths in the sun. Hot, hot, hot. When people think of the sun, they think of heat. The hottest part of the sun is its core. Remember, the core is the middle part. Temperatures there can reach more than 28 million degrees Fahrenheit or 16 million degrees Celsius. Stars are made of gases such as hydrogen and helium. These gases react with each other. That means they interact with each other, okay? They get very hot and cause small nuclear reactions. The reactions create energy which moves toward the surface. This causes stars to give off heat and light. So all of these things react or touch each other, and that makes a nuclear reaction. We have a few nuclear reactors on Earth, okay, that kind of do this, but it's different. Without going into too much detail, the reactors on Earth make energy, right? Just like you would have if you had coal or solar power, we'll talk about. Our reactors are called fission reactors. On stars, it's called fusion because hydrogen turns into helium. Okay. And that's how it gets its energy. The sun's going to burn out one day, but not in our lifetimes. I mean, we're talking 1 million years. Okay. And what happens to stars when they burn is they burn and burn and burn and burn, and they get bigger and bigger like a balloon, and they blow up and they become giants and super giants. And then they shrivel into a white dwarf and they get smaller. White dwarf stars are about the size of Earth. So those little stars are still pretty big. Okay. Now, we're pretty happy that we have, yes, Yolanda, ways that stars can die are black holes, protostars, all kinds of stuff. That's very good that you knew that. The sun is hot, yeah, for the Earth. So we're just in the right spot. Let me show you one little thing about the sun, and then we will keep moving. I've got a couple of these to show you just because I found lots of cool stuff about the sun on the brain pops. I'm not going to just show you the brain pops. Okay, so I want to show you this for just a second. Okay, Moby's at it again. Look at the shirt, the little boy's shirt. Tim always has what they're talking about. And there's Mr. Earth. Earth is just close enough to have liquid water and frozen water.
Dear Tim and Moby, why is the sun so hot? From Arthur P. The sun is actually a star, the closest one to Earth. That's why it looks so much bigger and brighter than the stars we see at night. Those other stars appear tiny because they're so much farther away. Even though the sun's closer, it's still 150 million kilometers from Earth. If it can burn our skin from that distance, imagine how hot it is up close.
Wow.
Well, the sun is way hotter than a stove. The photosphere, or surface of the sun, is close to 6,000 degrees Celsius. And if you
And this is the part of the sun that we see, the photosphere. Think of taking a photograph or a picture.
went down into the core of the sun, you'd experience temperatures around 14 million degrees Celsius. Right. Don't go into the sun. The sun is made of mostly hydrogen and helium. The sun's powerful gravitational field causes nuclear fusion reactions. That's when atoms fuse together to form new elements. This produces enormous amounts of energy, way more than enough to power all life on Earth. Some of that energy is harnessed by plants, which then get eaten by animals, who in turn get eaten by other animals.
Whoa.
There's also lots of energy left over. It heats up the ground, air, and oceans. All of this energy would create overwhelming heat if sunlight were constant. But most places on Earth get sunlight for just part of any given day. That's because Earth spins like a top, and only about half the planet can face the sun at any time. The other half faces away and gets a chance to cool down. That's nighttime. The Earth makes a full rotation every 24 hours, which is why a day is 24 hours long. Over the course of a year, Earth's tilt causes sunlight to strike at different angles, creating seasons. The sun dictates the seasons, controls the weather, and drives the water cycle. Take away the sun, and Earth would quickly become a frozen ball of lifeless rock. We're also lucky that Earth is just the right distance from the sun. A little closer, and all our life-sustaining water would boil away into space. A little farther, and it would all freeze solid. The sun was created out of the same cloud of gas and dust that formed the rest of the solar system. This cloud probably came from an old star that exploded at the end of its life, as stars sometimes do. Today, the sun contains 99.8% of the mass of the solar system. That's almost everything.
So they're showing you here all the planets
And in case you were wondering, this
planets in our solar system. Okay, so that's what he's showing you, like my necklace had all the planets, and the sun is what they all go around. But of our solar system, with the planets and the sun and all the little rocks around called asteroids, most of the mass of the whole solar system is the sun. It's that big. So that's what he's trying to say.
The sun is middle-aged. It's about 4.5 billion years old, and it's got another 4 to 5 billion years to go. At the end of its life, the sun will expand into a red giant. That's the first phase of a star's death, when it's run out of hydrogen fuel.
See, it's getting bigger.
It'll reach all the way out to where Earth is now, and then throw off its outer layers as a planetary nebula. These days, the sun is a very active place because of its gigantic electromagnetic field. Enormous jets of burning gas called prominences can erupt thousands of miles into.
These are called solar flares or prominences. I'm going to show you that in just a second, but they're little eruptions. They're giant. They come out from the sun. They'll never, ever reach Earth because the sun is so far away, but they're big explosions that come out all the time. Okay. They may play a little tricks on you with your electronics sometimes. They might say, we're having a solar storm, and maybe your phone doesn't work or your laptop might not work for a minute. And so that's what that is. But they'll never, ever touch Earth. They're too far away, but they're giant flares or giant shoots of stuff that come out from the sun, but they're very far away from us.
Into space. And strange dark patches called sunspots appear on the sun's surface. Sunspots, as well as other solar activity, seem to...
Okay, these sunspots here, guys, the sun has black spots on it at times, and sometimes it has more, sometimes it has less. They're the size of Earth. That's how big those spots are.
Follow an 11-year cycle. The sun's atmosphere, or corona, can be seen during an eclipse. Which reminds me, don't ever look directly at the sun. Powerful solar radiation can blind you for good, and no one wants that. Likewise, you should wear sunblock when you go outside for long periods. The ultraviolet radiation that the sun gives off can cause permanent damage to your skin.
Like sunburn.
So respect the sun. Love the sun. You don't have to take care of the sun. It does fine on its own.
Ha ha. Okay, let me go ahead and stop there. Okay, so they just showed you the sun, and they showed you the parts of the sun, like I went over, and also the spots on the sun that can be pretty big. Okay, yeah, the sunspots are big. They're black, they're dark. Sometimes when there are more sunspots, we have weird weather on Earth, like maybe some droughts, which means not a lot of rain, or the opposite. So sunspots can kind of play tricks with our weather sometimes. Okay. All right, let me go to the parts of the sun since they were talking about that and show you a couple other things. I've got so much to show you guys. I've got too much to show you guys here. All right, so here is my PowerPoint again. Here's parts of the sun, like Tim just talked about to Moby, and we talked about a little bit in the book so far. The sun is 4.6 billion years old. Sunspots are cool areas on the sun. See the sunspots there? So what they did in this picture, they like sliced what the sun looks like. They took a slice out of the sun so you could see the inside too. The core is the inside where we have fusion happening. Hydrogen's turning to helium. So it's bright, bright, bright. That's how we get the energy from the sun because nobody's plugged it in with a battery, right? It just stays bright. The photosphere is a layer that we see. And like Tim said, never ever look directly at the sun. Then you have the chromosphere. And then you have the outer little crown, like a queen or a king would wear, called the corona. Okay, so there's some flares here. See these, they call them prominences if they loop back down, or they're just flares if they come straight out. I've seen these with a solar telescope. You have to have a special telescope. I'm going to show you what that looks like. Okay, here it is close up. See the flares? You've got these giant, giant things coming off the sun, but they'll never touch us. They're just too far away. It's pretty cool though, right? And that's all gas. It's not anything you can touch. It's not solid, because remember that the sun doesn't have anything solid. Okay. Some of the outer planets like Jupiter and Saturn and Uranus and Neptune, they're all gaseous, but they think they might have a solid core because they've seen comets go through and stop. Comets are big things from space, so scientists aren't really sure. And I'm going to be doing different webinars on all the planets in the next coming months, all the way through the summer. Okay, so let me go back to this since they talked about this. Let me go to my model. Here's Mr. Sun. Now, if I had this to scale, this would be like the size of our room compared to the little guys here. Little moon, our best buddy, and here's the earth. Okay, and you guys are over here on the dark side right now for nighttime, and the sun's just coming up here. It's beautiful out. Okay, so this goes around, I'm going to make this kind of 3D. This goes around the sun in 1 year. That's how we have a year, right? Okay, that's called its revolution. Like Mars takes twice as long to go around the sun. They have like their year is 600 and some days. Ours is 365. Anybody know how long it takes Mr. Moon to go around the Earth? I'm going to do a webinar on the moon too, but how long does it take the moon to go one time around the Earth? Anybody know? Oh, that's right, Yolanda. You're on my continent. That's right. You're in morning. Anybody have any ideas? It takes us 1 day to turn, right? Because you guys are nighttime, except for Yolanda and me. Okay, that's 1 day. It's good, Ellie. It takes 1 month because we go through the phases of the moon. Exactly. So this takes 1 day to turn. This takes 1 month to turn. And we both go around the sun in 1 year. Okay, that's called a revolution. Rotation is what we do every day. Like you guys are back here, you don't see the sun, it's nighttime. I'm over here and I see the sun. So rotation means like this, I'm just rotating, okay? But we go around something, that's called revolution, or revolve around something, okay? Let me show you, let me get rid of Moby for a second. Let me show you some things about the sun. I told you I had a lot to show you guys today. Never ever look directly at the sun. This person is, but they've got a special lens on their camera, okay?
It rises in the morning, giving light to the land below it. It sets in the evening, leaving the world in darkness.
No matter what country or place you are on Earth, the sun always rises in the east and it sets in the west. You know, in compasses, they have a north, a south, an east, and a west on a map. So no matter where you're at, the sun always rises in the east and then it sets in the west. And like I told you guys, Perseverance, or Percy, the Mars rover, just got pictures of this happening on Mars, the sun setting. Mars is further than us, but still pretty cool, right? Mars has seasons like us. They're just twice as long because it's twice as long for a year.
It even provides the heat and energy necessary for life to survive on Earth. You know what I'm talking about. The sun. Because it is so important to us, the sun has been studied and observed since ancient times.
Wow.
Astronomers today still study it and are constantly learning new things about the sun, the center of the solar system. The sun is a star, not so different from the stars that can be seen in the night sky.
It's closer.
It may look different, but that is because the sun is many times closer to us than any other star, which allows us to see how hot and bright it is. The sun may be close to us compared to other stars, but it is still very far from the Earth, about 93 million miles or 150 million kilometers away.
Wow.
Although the sun is so far away, it only takes sunlight about 8 minutes to reach the Earth because light travels so fast. Because the sun is so
See, they're showing you the different orbits here. So here's the sun in the middle, and the next closest planet is Mercury, little guy. Okay, one side of Mercury is super duper hot, and the other side super duper cold because there's no atmosphere. And then you have Venus, which is our twin, and then you have Earth, which is us, and you have Mars. Okay, so these little circles are just showing you how it goes around the sun. And then, of course, we have some, we have a band of rocks out here called the asteroid belt. Then we have the big guys, Jupiter and Saturn and Uranus.
far away, however, it seems much smaller than it really is, more than 100 times the width of the Earth. The sun is so large that if it were empty, more than 1 million Earths could fit inside.
Wow.
The sun is the largest object in the solar system. In fact, if you collected everything in the solar system, including the sun, the planets and dwarf planets, comets, asteroids, and moons, the sun would account for more than 99% of it.
We just said that. Remember in the other video? So here's the sun, here's Mercury, Venus. Venus and Earth are twins. We call that our twin planet, even though it's not very much like us with the way the temperature is. But Magellan was sent out by NASA and it mapped it. It looks just like Earth, but without running water. But you wouldn't want to go there. Okay, there's intense pressure and sulfuric acid for rain. It's very, very intense. So here's our little moon with us. Okay, notice they don't have a moon. Mercury and Venus don't have a moon. Then you got Mars. Mars has 2 moons, and that's where the rovers are right now. So this is the orbit, like I said, the revolution. Then you have all these tiny rocks, leftovers from when the solar system formed. They're called asteroids. And then you've got Jupiter, Saturn, Uranus, and Neptune. And what's deceiving about this picture is that Saturn has rings, but guess what? They all have rings out there. Jupiter has rings of ice and dust and gas. So do the other ones out here, these 4. Okay, here's a comet. So I'm going to do another webinar presentation on comets and meteors and things like that. But we're just talking about the sun today. I figured we'd start there and then we'll go through some other planets, okay? Let me stop there for a second. I want to go back to our book and then go back to something else. Okay, so we talked about parts of the sun. The photosphere is the part that you would see if you looked at the sun, which you shouldn't do, but maybe you have a solar telescope. I'll show you one of those in a second. The sun's surface or photosphere is very active. It is 300 miles or 483 kilometers thick. The photosphere is not a hard surface. Remember I told you guys you can't land there. Instead, the sun's hot fluids move above and below the surface. This causes the surface to have granules or bumps that last about 10 minutes. The large bubbles of hot gas move upward through the zone. Then sunlight escapes into space. Sunlight provides light and heat to the other planets. Yay for sunlight. And the sun has a life just like us. Okay, it goes through being a baby. All stars are babies. Then they grow to be kind of happy and adults, and then they get older and older and older. So right now, our sun is like a happy adult. We're happy he's happy, right? He's not just born, and he's not going to die anytime soon. The sun's life, the sun is about 4.5 billion years old. Like other stars, it began as a cloud of gases. As a gas cloud rotates, remember, rotates like this. Rotate means I move around in a circle. Heat and pressure begin to build. Soon the mass begins to collapse on itself. At 20 million degrees Fahrenheit or 11 million degrees Celsius, the gas begins to burn. And after several nuclear reactions, a star is born. Right now, our sun is a yellow dwarf star. Because of this, scientists think it will last another 4.5 billion years. So it's not going away anytime soon. When our sun begins to die, it will expand. Expand means it's going to get bigger and bigger and bigger. Eventually, it will become a red giant star. After about 500 million years, the sun will shrink again. Then it will become a white dwarf. So it's going to go from a baby where they can't really shine. It's called a nebula and a protostar. And then it becomes a main sequence like it is right now. And then it starts expanding and dying. But like we said, it's going to be a long time before the sun goes away. Speed of light. In space, distance is measured in light years and lasts minutes. 1 light year is the distance light travels in 1 year. This is very fast. Light travels nearly 6 trillion miles or 10 trillion kilometers in a year. The sun is the closest star to Earth. It is 8 light minutes away. Proxima Centauri is the second closest star. It's about 4 light years away. So Proxima Centauri is much further than the sun. Okay, and see how it says here how we measure things. Miles and kilometers are one way to measure distance on Earth. But for space, scientists need to measure distances that are far greater than distances on Earth. So I couldn't use, miles or kilometers to really tell you how far the sun is because it's just such a big number. Light travels very fast. So scientists found a way to use it to measure distance. We are in a solar system. Okay, in our solar system, we have our planets, like I showed you guys. Okay, we have Mercury, Venus, Earth, Mars, and then we have Jupiter, Saturn, Uranus, and Neptune. That's our solar system. Lots of solar systems make a galaxy. Okay, and lots of galaxies make a universe. Okay, so it kind of goes from littlest to biggest. Okay, yeah, so the Milky Way, right, Yolanda, is our galaxy. It's also a candy bar, but the Milky Way is our galaxy. Okay, let me show you another thing about the sunspots and parts of the sun. This guy has a solar telescope. He's taken the cover off of it. He's going to look during the day, right? He's not going to look at night for the sun. He's going to look during the day. Okay, so these are the pictures that he took. He had a camera on his telescope, and these are the pictures that he took. That's pretty cool. You got to be real careful too, because you don't want to burn up your lens and your camera. It's pretty hot. Just like looking at the sun's not good. So these are sunspots. They're about the size of Earth. Sunspots are temporary phenomena on the sun's photosphere that appears as spots darker than the surrounding areas. Phenomena means occurrence. They are regions of reduced surface temperature. Okay, so they're not as hot as the sun, but they're still pretty hot. The next day, okay, so these are pictures in motion. You can see it kind of move a little bit. Remember, you can't stand on a sunspot. Everything's gaseous there. He's using this type of camera, he's saying. Okay, granulation, our book just talked about, kind of granules, like think of sand particles, but it's not sand, it's gas. Closer up. He's still using his camera, but he's getting a magnified, a little closer picture. Okay. Anyway, so he's showing you a sunspot. I want you guys to see that kind of up close. Kind of cool. Okay. Now there's a famous scientist called Neil deGrasse Tyson, and I'm going to show you a little bit about him talking about the sun. Okay. And he's got the planets kind of behind him. He's got a show as well, but he's an American that talks a lot. He's based at the New York City Planetarium where I've been. This is what he looks like.
DeGrasse Tyson. I'm an astrophysicist with the American Museum of Natural History, and I'm host of Star Talk Radio. Welcome back to Star Talk Radio. And it's fighting all these air molecules. Like, what's up with that? We win. Astrophysicists win. Oh! Yeah, I said it. Snap! Bada bing! Wow, 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 wow.
So he's a big scientist, and he tries to be really, really cool. He's going to talk about solar flares now.
An active, churning, convecting place. And let's say you're making oatmeal in the morning, and you put a little too many oats in your boiling water. Keep the flame up high, it gurgles violently, and the oatmeal is sputtering on the stove top. That's what the sun is doing. And occasionally, one of these spurts, the sun is made of a charged gas. We call it a plasma in physics vernacular. And this charged gas breaks free of the surface. It spews out into space, sends a blob of plasma across interplanetary space, and occasionally one of those heads towards Earth. You don't want to be in space when that happens because it can sort of ionize your atoms in your body and interfere with the functioning of your DNA. That would be bad. So we're protected here on Earth because we have a nice, safe magnetic field that deflects these charged particles. They collide with the atmosphere, renders the air aglow, and it is the source of the aurora borealis and the aurora australis, the northern and southern lights. So those are otherwise dangerous particles from the sun rendered harmless and rendered beautiful.
Pretty.
If you have a large enough solar flare, it won't all...
So he's saying that solar flares can't hurt Earth. We have a charged magnetic field. And sometimes if you're in Canada, even Yolanda, or further north, you can see the northern lights at certain times of year. And sometimes if you're in the southern hemisphere in Australia, you see these southern lights. And it's just this beautiful glowing in the sky. It doesn't move back and forth. It's like looking at just a pretty sunset. And that's what those are.
Get directed to the pole, some of it can get all the way through and it can disrupt our electrical grids. It changes the current that moves through. It boosts it in some areas, reduces it in others, and you can override the transformers at certain electrical checkpoints. That's happened before, it could happen again. More important than that is we have electrically run satellites orbiting Earth. They are susceptible to solar flares.
Right.
So the more we put up in space, the more at risk our communication, our space-based technology.
Lots of satellites in space for cell phones and weather satellites. And he's just saying that those things, the solar flares wouldn't touch them, but they could be kind of messed up because not that they come close, but they have all these charged like electricity, these solar flares. And that's not good for something that's out in space.
So the future of that is what we call radiation-hardened electronics that can survive these blasts from the sun. But the sun has been doing it forever. Nothing new happening now. We're still here. We're just fine. Now we can...
Okay, so there's a satellite. It would never ever touch us or the satellite. Just the stuff in space could transfer electricity to it, is what he's kind of saying. Okay, all right. Let's talk a little bit about eclipses, which are when we don't see the sun or the moon. Let me show you this. Okay, so that's it for parts of the sun. I could say more and more about that, but we're going to keep on moving. Okay, so I just showed you the solar flares and the prominences. Okay, we talked about what a year is on Earth. I showed you with the model I have here. It takes a year for the Earth to go around the sun, and that's why we have seasons. Okay, now sometimes you can have things blocked out, meaning I don't see the sun during the day, not because of the clouds, but because the new moon goes in front of the sun. So I'm out there, I have eye protection on, okay, and I'm looking and I know it's going to happen and it's clear out. It's during the day, not at night. And I have the new moon move in front of the sun. That's called a solar eclipse. Okay, so you can't see the sun because just for a little bit, because the new moon, it has to be the phase of the new moon, not the full moon, goes in front of it, and it kind of slowly takes away the sun, and then the sun kind of appears again. I saw one of these a couple years ago. I'll show you that in just a second. But it's almost to where the animals even think it's nighttime. The birds go to sleep and the crickets stop chirping, and then the sun comes back out, and they're like, "What just happened?" So that's called a solar flare. I mean, solar eclipse. Excuse me. Let me show you about that. And there are also lunar eclipses, which mean eclipses of the moon. This guy is going to see a total solar eclipse, and he's happy because it's not cloudy out. Because if it's cloudy, you can't see the sun during the day. So it's different times of day, and they're very rare. You have to go to the spot on the earth where they're actually going to happen. Okay, so I'm going to forward a little bit through this, but this is a total solar eclipse in 2017. It's the same one that I saw.
1st, 2017, the day of the total solar eclipse. I'm in Madras, Oregon. The skies are clear. This is my sky tracker. It's meant to move the camera with the sky, so it sort of compensates for the Earth's rotation. That should help me keep the sun in shot as the eclipse is taking place.
Okay, so the sun's coming up during the day. You're not staring at it, but he's got special glasses. He can do that.
First contact. This is C1. You can just see the moon entering on the top right side.
See how it's slowly taking away bits of the sun? Kind of looks like a half moon or a full moon or a quarter moon. That's kind of, but it's the sun during the day, so it's getting darker and darker and darker out.
We are 17 minutes out from totality, and I think the light is starting to change.
Totality means the whole thing is getting ready to happen. Oops, and I just went backwards by accident. Sorry about that. Let me go back to this guy. Hold on. I gotta get through this ad. Okay, there he is.
Dimmer. There's a bit of like a cold wind coming in from this side. Can you guys feel it? It's getting kind of cool, and it's getting darker. I'm really excited. Now that the sun is about 90% covered, I'm seeing much sharper shadows. Normally shadows, they're a little bit fuzzy because the light from the sun is coming from a whole bunch of locations, but now because it's coming from basically one little sliver of the sun, the shadows are all getting very, very sharp. Oh my God. Oh my God. Ah!
Guys, look around. Just try looking around.
This is insane right now.
Getting dark.
Oh, this is just unbelievable. What?
Oh my God!
What is happening? This is absolutely insane.
There's the beads.
I feel like it's hard to breathe. Oh my God.
Okay, so this is during the day. It's called a solar eclipse.
Really creepy.
Oh my God, the sun!
Oh.
And you can see the little flares up there popping off a little bit.
Weird.
Look at the sunrise, Derek! It's at every direction!
Oh my goodness. There's like sunset, sunrise, every direction. People are going nuts. This I did not expect. I don't know what I expected, but...
Oh my God!
Okay, so it's only lasting for a couple minutes, and now it's going to start getting sunny again.
You can see these prominences, the solar corona coming out, the top left
corona?
and right and the bottom. I can see Venus directly above me. You can see the stars.
So it's pretty cool, right? So then it starts to get light again.
Can you guys feel it? It's getting kind of cool, and it's getting darker. I'm really excited.
Oh, okay, I went backwards by accident. But anyway, you guys saw the totality, right? That means the whole thing happened. That's pretty neat. Okay, let me show you. Let's talk about protecting our selves from sun. I want to show you this eclipses thing for just a second. And I don't want to make sure I show this. I'm not going to show you the whole thing, but here's how eclipses happen. Remember, there could be a lunar eclipse of the moon too. This is an eclipse of the sun he just showed us.
Huh. Did you put my croquet cleats in the freezer? Dear Tim and Moby, what is an eclipse? From Geodude 11. Moby, we saw an eclipse a couple years ago. Don't you remember that thing we made so we could look at it safely? No? Right, that eclipse. If you hear that there will be an eclipse in your area, that means that our view of the sun or the moon is going to be blocked for a period of time. The moon orbits the Earth, and the Earth orbits the sun. When the moon blocks our view of the sun, we see a solar eclipse. And when the Earth gets between the sun and the moon, we see a lunar eclipse. Yeah, looking at this model, you'd think we would have a lunar eclipse every time the moon was here, and a solar eclipse every time it was here. In other words, a couple dozen eclipses every year. But in reality, the moon orbits the Earth on a tilt from our orbit around the sun. So, in most cases, the moon's shadow misses the Earth, and our shadow misses the moon. But a few times every year, everything lines up right, and we get an eclipse. You've probably seen a lunar eclipse. They can only happen during a full moon, when the sun and moon are on opposite sides of the Earth.
At night.
Sometimes, the moon passes only through the lightest part of the Earth's shadow. This is called a penumbral eclipse, and it makes the moon...
Okay, so remember, a lunar eclipse is at night. A solar eclipse means sun, and that's during the day. Okay? And lunar eclipse is a lot more common. Those are going to be 4 this year, I think. But for a solar eclipse, you've got to be right in the shadow, the right part of the shadow. Let me go right where he talks about it. So the right part of the shadow, only these people on Earth could see the actual solar eclipse. This outer, lighter shadow, you might see a partial eclipse and some of the sun taken away, but not all of it.
Solar eclipse happens where the direct shadow, or umbra, reaches the Earth. The moon is much smaller than the Earth, so its shadow can't cover the whole planet. The umbra will only fall along a thin strip of the planet's surface. This is called the path of totality.
And that's what that guy was in, okay? He was in the path that saw the whole thing. A few years ago, the same eclipse that he saw, I was on the other coast of North America. Okay, he was in Oregon, and I was in Virginia, where I live. Let me show you this. This is a picture of me. I went to the beach to see it, okay, because I was going to go down to where to South Carolina, but I figured let me just stay closer to home and let's go to the beach. It was a sunny day. It was in August, and let me show you this picture. This is me and my kids at the time. Oops, hold on. Here we go. Okay, this is us watching it on the beach, my daughter, my son, our glasses, our special glasses for solar protection for our eyes. Here's what we saw as the sun was getting smaller and smaller and smaller. We were in Virginia Beach. So we were at the beach that day, and we knew it was going to happen because it was in the papers, and we thought, okay, this is pretty cool. So we ended up going out and seeing it. There's me and my son and my daughter. Neat. Okay, here is, I want to talk to you about make sure you have sun protection. That means sunscreen and good sunglasses every day, not just a day of an eclipse. Okay, I'm not going to get to show you this about sun care, but I wanted to make sure you understood that. This is kind of a neat picture I got. Now, let me show you this. These are solar cells or solar panels. They are used for solar energy. When you hear the word solar, you think sun's energy, right? And this is how you can generate electricity instead of burning coal into a dirty, dirty factory and a power plant that we all get electricity from. These are solar panels, okay? Has anybody ever seen solar panels or learned about them? Let me know in the chat. Anybody ever learn about solar panels or solar energy? Your calculator might have a little solar panel on it, so it doesn't need batteries. It doesn't have to be a house. It could be something small. Okay, yeah. So let me show you. So Ellie says, yeah, Yolanda, our neighbor has it. Yeah, a lot of people are putting them on their houses. I don't have it on my house, but I know people that do. My school has it though, okay? This is my school where I teach. This is the top of my school. and you guys can see the solar panels. So the electric company said, you have the perfect roof on your school. Can we use it? And they ended up doing this a couple years ago and putting solar panels, and it's not just for our school, it's for the city, and it goes right back to the electric lines, and other people can use it because they said our roof had just the perfect pitch, the perfect angle to have solar panels. Okay, I went up there and took a class on this. So this is up close. I got to go up there. Not many people did. This is what it looks like up close. See how the solar panels are kind of tilted or angled, and they get the perfect amount of sunlight. Okay, so that's what it looks like at the top of my school. Here's me with all the solar panels. It was a hot day, and it was so hot that day I could see why that was the perfect roof to have these solar panels. Okay. Here's another close-up picture of what they look like. They're called solar cells. Okay, and they say that sometimes they get dirty, but that rain washes them right off. Okay, here is a place installing solar panels. See what hard hats, they're putting them on the roof. You can move from using coal and electricity to using solar power. Let me show you one in China. This is a place in China that has lots of solar panels. They built a solar farm. It doesn't mean they farm for, chickens and horse and stuff like that and cows. They have a place they just use for solar panels. Oh, really, Ellie? Okay, that's awesome. This is a place in China that has them. Okay, kind of pretty, but they took all this land that nobody was using and they put solar panels on there. It's called a solar farm. Okay, so it uses solar energy. Kind of pretty. Okay, let me show you this. This is my school, like I showed you. This is they might show you close up. Close up here, sorry. This is a little video, but I'm going to show you something else after that so we can take questions. This is kind of like the picture I showed you. My school is called Western Branch High School.
The dedication of this solar array marks an important step in our journey to a cleaner energy future, and the Chesapeake Public Schools should be proud of its leadership in that effort. This installation consists of 3,000 panels that will generate 800 kilowatts of electricity. That's enough energy to power about 200 homes at peak output, all from the roof of a single school. That makes Western Branch High School home to the largest single rooftop solar array currently operating in the Commonwealth of Virginia. This project also marks the intersection. I wanted to show
you that just because it was a video. Now let me show you one more thing about solar power. And we'll have time to go back to our book. Solar energy, not using coal or gas or anything dirty that could burn.
Carrying around an egg all day just to do that?
It's hot.
Dear Tim and Moby, if fossil fuels pollute the environment, then why don't we just switch over to solar energy? From Terry. Well, the short answer is that fossil fuels are still much cheaper than solar energy. But unlike fossil fuel, solar power is a renewable source of energy, so researchers are constantly working on ways to harness sunlight. A renewable energy source is one that comes from a natural, ongoing process that will continue into the foreseeable future. Solar, wind, and hydroelectric power are all renewable energy sources. Oh, there are lots of ways to harness the sun's energy. Thermal collectors use sunlight to warm water, which is used to heat buildings. And spacecraft can use solar sails to convert sunlight's force into motion.
A lot of our space satellites and like the Hubble telescope, they have solar power. That's how they use that. And that's what the rover has on Mars. That's how they don't have to take a battery with them. They use solar power.
But when most people talk about solar energy, they're referring to the use of photovoltaic cells or solar cells. Those are those dark panels you see on solar-powered devices like calculators and satellites. Photovoltaic cells convert sunlight directly to electricity. No, sorry, it's too complicated to explain. I'm just kidding. A photovoltaic cell is essentially a thin layer of a semiconductor, like silicon, covered in glass and plastic. A semiconductor is any substance through which an electric current can pass with some effort. When photons, or light particles, strike the solar cell, they knock an electron loose inside the semiconductor.
And that's how they have
the space left by that electron gets
solar panels, okay? So without, watching this, because we don't have time, I wish we did. That's basically how you have your solar panels getting that dark colors attract light, attract the sun. They get hotter. So that's how it makes the energy. And the ones on my school actually have so much electricity that they generate, that means that they make, that it goes back up to the electric lines and other people can use it. That's kind of neat. Okay. So before I take some questions, you guys remember that we have the sun here, the moon here is our friend. He goes around in a month. Okay. And then we hold hands. Okay. And we go around the sun. How long does it take us to go around the sun again? Somebody tell me in the chat, how long does it take us to go around the sun? A year. Good, Yolanda. Yep. And just like we talked about here, the sun's here and all the planets go around the sun. And like our year is 365 days. Mars has like a 600-day year. And then say Mercury goes around the sun because it's so close in 77 days. So the further out you go, like to Jupiter, the longer the year is. Okay. All right, let's go ahead and take some questions. Yeah, Lisa, that was an egg. Funny. Let's go ahead and take questions.
Hello.
Hi, Yolanda.
Hello. My question is, can other stars become the sun?
No, they have their own solar system, and so they have other things that go around them. But yeah, just our sun is our sun because that's what powers all of the planets in our solar system. That's like our one star. It looks like when you're on Earth, there's tons of stars. They are, but they're not close to us at all. They're even if they're close together, they're very far apart.
Thank you.
Yeah, thank you.
Hey, Susan.
Hi.
I think it's great that you talked about the sun today, and I like to ask a question about that sun. That sun, they have the amount of energy. If the energy runs out one day, how would people do? And if people don't have any energy, the earth from the sun, and so will people go like push the earth out of the solar system to find other stars, or people will do something to make the sun keep burning? Like just a few years ago, China had made a movie about people putting earth away into other solar systems to make the earth keep surviving because the sun is running out of power. So do you think is there any ways to solve this problem about the sun's energy?
Yeah, when the sun goes and burns out, Brandon, we're done. We're done. We can't move anywhere unless, we find, and people are already looking at other places to go just because maybe our resources would run out. But when the sun is gone, we're done. That's it. We can't move the earth. And actually, Brandon, when the sun does get bigger or when it dies out, remember I told you it expands. So even before it dies, it's going to be too close to earth. And we're not going to be able to be alive. So we'll be gone way before it even dies out, because when it expands, it gets closer and closer to the earth, like a star does. It becomes a giant or a super giant, and then it shrivels up into a white dwarf.
Oh, okay. Yeah, thank you. My
sure.
Well, I didn't see any more hands up now. So how about you share a little bit more then?
Sure.
Okay.
Absolutely. Sure. Okay. I'd love to. All right. So let me make sure there's not a question. I see. Okay. Yolanda just gave thumbs up. All right. Yay, Yolanda. Let me go back and show you a little bit more. I love to have more time here. I talked about keeping your skin very safe and very protected. Let me get rid of Moby there for a second. And you want to make sure that you wear sunglasses to protect your eyes, and you want to wear sunscreen to protect your skin. Because has anybody here ever had a bad sunburn because you've been in the sun and you haven't had sunblock on, or maybe you haven't, it was just too intense? Not a good day when that happens. Let me show you a little bit about sunscreen, and then we'll go back to our book if we have time.
Where are you, you big orange goon?
Uh-oh, look at him.
Did you replace my sunscreen with sour cream? No, I don't think it's funny at all. I'm burned to a crisp, and I smell like a baked potato. Dear Tim and Moby, why should I wear sunscreen when I go outside? Sincerely, Addison. Well, the sun gives off massive amounts of radiation or energy, only some of which you can see. In addition to visible light, it also sends out invisible ultraviolet or UV rays.
We can't see them.
Yep, it's UV rays, not visible light, that penetrate your skin and cause you to tan or burn. There are 3 types of UV rays. UVC rays are the most powerful, but they're blocked out by the Earth's ozone layer. UVB rays affect the outer layer of your skin, the epidermis. When you're
That's supposed to be a picture of your skin. That's the hair that comes out of your skin.
exposed to a lot of them, you get a sunburn. There are no safe UV rays, but UVB rays are thought to cause most skin cancers. UVA rays, on the other hand, can penetrate much deeper. At the deepest part of your epidermis are cells called melanocytes. They produce a chemical called melanin. It's a brown pigment that darkens your skin. When UVA rays hit your melanocytes, they start producing melanin, and you get a tan. Why does that happen? UVA rays can penetrate your skin all the way down to your dermis, where your nerves and blood vessels are.
Again, this is your skin. Okay, this is the hair follicles in your skin. So if you don't wear sunscreen, not good. All right, not good at all, because you can get a burn. Let me show you a little bit. Make sure that went back to the to our book. Let's go back to our book. And like we started talking about the Milky Way. Lots of solar systems make up a galaxy. A galaxy makes up a universe. Groups of stars form galaxies. A small galaxy has about 10 million stars. A large galaxy may have up to 1 trillion stars. Our galaxy is called the Milky Way. It is a large galaxy. Our sun is just one of the many stars in the Milky Way. Here's our solar system. We've been talking about this like my necklace. Our galaxy is filled with solar systems. A solar system is a single star. You guys remember our single star, the sun, with space objects such as planets orbiting it. Orbiting means going around it. Our sun is at the center of our solar system. Earth is one of the 8 planets that orbit our sun. The other planets are Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. We don't include Pluto as a major planet anymore. He's a minor planet, a dwarf planet. We have about 300 to 400 dwarf planets. So instead of memorizing all of those names, we just memorize the top 8. Okay. The sun is the only star in our solar system, but it is one of 200 billion stars in our galaxy. Some scientists think our galaxy may have as many as 400 billion stars. Our amazing sun. Many interesting events occur on the sun. Some of them, such as sunspots, happen on the sun's surface. These dark spots are not as hot as the surrounding areas. I told you guys they are about the size of Earth. They're still pretty hot, but they're cooler than the other parts of the sun. The number of sunspots found on the sun changes. Sunspot activity peaks every 11 years. Peaks means a lot. Every 11 years, there's a lot, like the mountain peak, the top of the peak. The sun is also the source of solar wind. Solar wind is not like the wind on Earth. It is created when energy escapes from the sun's surface and gravity. The outermost layer of the atmosphere is called the corona. This layer is larger and hotter than the chromosphere and the photosphere. Remember, we only saw it during a solar eclipse. Every so often, an explosion occurs in the sun's atmosphere. These explosions are called solar flares. See the flare we talked about? It will never reach Earth. Most flares occur around sunspots. Discovering the sun. Stars have been important to people since early times, and people have always seen the sun. But for a long time, they didn't know that it was the center of our solar system. In the 1500s, Polish astronomer Nicholas Copernicus said the planets circle the sun. This was a very important discovery. Many people said the idea was wrong. Guys, they thought that all the planets went around Earth. That's what they used to think. And he said, no, look, the sun, we're all going around the sun. And a lot of people didn't believe him. But eventually it was proven correct. In the 1600s, Italian scientist Galileo Galilei used a telescope to study the sun. He discovered sunspots on the sun's surface. And Galileo, they think, discovered the telescope, but he didn't. He just used one of the first types of telescopes in the 1600s, a very famous scientist. But for a long time, they said, no, all the planets go around the Earth because the Earth is us. No, we all go around the sun, just like we talked about here. Okay, I don't have all the other planets here, but I've got the moon and the earth, and it takes us a year to go around the sun. And for some planets, it's longer or shorter. Like I said, Mars has twice as long as our year. Mercury has a really short year. Okay, but a long day, actually. Their day is twice as long as our day. Well, I hope you enjoyed the webinar, guys. Next week, I'm presenting on Saturday. And on Saturday, we're going to talk about a book called Barbie, and it's not just about Barbie. So please, if you're a boy, feel free to come, because I'm going to do one on Legos later in the month that girls and boys can attend. So please try to come next weekend. Have a great rest of your evening. Have a wonderful week.